Okay, so we're gonna go over RAM analysis today. There's some issue with the lab, and I'm hoping that we'll be able to fix it. I think it's just because the image has been moved. So I'm gonna try to see if we can download the image from another source in order to do the Cridex lab. If not, we have to analyze another image or another infection. Um, so today we're gonna cover chapter 7, which is unit 7. In this week, we're going to talk about RAM analysis for forensic. This is a very important area all the way around because all your computing systems require RAM to run applications. RAM is going to tell us a lot of things from, the type of applications that's being used. Sometimes in the case of you might have credentials that's stored in RAM. And then all the activities that's happening with the system is stored in RAM. So at the beginning, we need to talk about the fundamental for RAM, which is random access memory, what it is, right? So your system require RAM to be able to load applications, to be able to establish the running state for the system. And in order to take a look at the processes to run the program, it needs to load it into random access memory. This is volatile, right? We need power in order to be able to store in RAM. If you don't have power, right, RAM will not be able to store anything. And sometimes information stays in RAM, and then sometimes information gets rewritten in RAM, just like any other storage. So it's important that when you have a system that you're doing forensic on, do not turn it off because that changes the state of the RAM. Okay, we talked about that before because it changes the state of the system. So it's important that we keep the system intact. Sometimes we need to do a live analysis where we have to do it as it's being turned on, and maybe it's running an application, maybe it's being used for different things. And then sometimes we do a dead analysis where we actually use a snapshot of that particular system. Just like your disk drive, you can use a snapshot of your RAM. You can create an image of it, right? An image of a running system, and then you can examine its storage. So when you shut down the computer, right, your data sometimes gets flushed from RAM. So we want to be able to make sure that you capture the RAM before you change or shut down that system, right? So at the beginning, it goes over random access memory. This is a storage device. And in our computing system today, whether it's internal storage or what you see is your only external disk is going to be external storage, but RAM is built within 4 processes and application. So there are several different types of RAM. We have static RAM and dynamic RAM. The majority of your systems today, like your PC, it uses DRAM, right? It's actually SDRAM, synchronous dynamic RAM. This is a faster type of RAM. Now, static RAM is often used for more internal, like processors type of storage, a little bit more expensive in the cache mechanism for a lot of different type of processor. Static RAM is not as popular. So when you upgrade your RAM on your computer, that is a dynamic RAM, but it is synchronous. So we have SRAM, DRAM, and SDRAM, right? So that's really important to really think about, is that there are dynamic RAM that's being used in your internal systems, right? Like your PC. These comes as modules or chips, and they can be integrated onto the board or attached to the motherboard. On the PC, you often see that we install it onto a bus. That's how we can connect it to the board. Okay, so let's answer some questions. So the first question asks you, what type of information can be found in RAM when conducting digital forensic investigation? Number one, you can find information about your system current state before it shuts down. So that would be important. Maybe an application that's being ran or used. Some temporary storage information is also essential in our investigation. So information about your state of your system before it shuts down. Information about running programs, processes, legitimate processes, or in the case when we're looking at malware, that's very important for us to examine the RAM. Because ultimately, malware is a code or a software that's written to perform a certain type of task. So with that, it normally uses drive space and RAM in order to run, in order to execute in certain processes or initiate certain processes. It requires RAM. So when you are analyzing malware, it's important that we examine RAM. The third thing that we would find in RAM is your network connectivity. Things like host information. So if I'm connecting to a certain system to share files, that would also show my connection in the RAM. So network connectivity information we can obtain from RAM. Also things like user actions in the system, user activities, activities that they committed to when they're using that system. So ultimately your computer is just hardware, right? Is controlled by the software, which is interfacing the user. So when the user utilizing the software, the majority of your software processes relies on RAM. Now, if the user use an application or, access a certain thing, that is also going to be shown in RAM. So those are the things, and you can find that information on the first page. I simply just summarize it. And then for our side, sometimes we need to obtain passwords, right? Passwords related to sessions, maybe online passwords. So browsing activity also relies on browser applications. And then sometime we would need to look at temp files or files that would come down. So your RAM is going to give you a little bit of information. And then anytime that you copy and paste, that goes into RAM, right? From your iOS to your Android to other systems. So anytime that you copy paste, that gets added to the clipboard, which is stored on RAM. Now, a user can flush out the clipboard by removing all of the information inside the clipboard, right? But it does store information that you can use, especially text. And then if you're using encryption keys, information would also be obtained from RAM. Now, encryption keys can be stored physically onto your hard drive or your solid state drive or a USB, right? But as it comes down, your encryption key information would also be retained in RAM. So we want to ask why the forensic investigator should avoid disconnecting the power in an investigation. Because your data is stored to RAM chips, which is volatile. And you can lose data when you remove the power. So when we shut down the computer or unplug it, we actually lose information when we remove the power. So anytime that you work with devices, right, or components that require power, we do not shut that off. Okay? Before you shut it off, you need to be able to obtain its image, its storage, right? We want to capture the image of the system and be able to analyze the image. Because when you shut it down and when we remove the power, we change its state. We would lose potentially all the data that we need, right? All the data here, potentially passwords, processes, all of those things. Now, if you have a system that's infected, we would then need to make sure that we isolate that system, take an image of that system, and then examine the system image, right? So in the case where you have to do malware forensic, you need to make sure that that system is isolated but not shut down, right? When we say isolated, that just means that it's not connected to the network. And we want to make sure that we capture the image and scan. Because we want to see the behavior of the malware and how that would impact the system, right? If the malware is not quarantined, then we want to make sure that it's not spreading. But in the case that if you have an attack, right, attack processes might occur. For example, the distributed denial of service. And if the attack is happening, if you shut down that system, potentially it would stop the attack, but it changes the information for us, so we will not know what had happened. So we need to make sure that we isolate that segment and making sure that that attack is not no further impacting other system on the network, and we need to analyze it that way. So in incident response, you often see forensic is very handy. So if you have forensic skills, when you look at incident response job for cybersecurity, you often see that. But if you go into more system forensic and for analysis, like for crime investigation, you would also need to make sure that you have proper procedures in how you handle your evidence. Okay? So again, we don't shut it down until we capture the image and it's safe for us to shut down. So, and then the type of RAM that you commonly find in your investigation, you would see static RAM, which is known as SRAM, and you should also find commonly especially in PC, is your DRAM, which is dynamic RAM. So when you buy DDR4 or DDR5, right? And if you have an older computer, you might have a DDR3 that is dual inline, right? Dynamic RAM. And they are all SDRAM. They're synchronous dynamic RAM. So it's able to write, right, dual inline for memory module. It's able to write on multiple cards at the same time. So when we're doing dual inline, we always want to pair them up. So you often see that when you install RAM upgrade, we want to have 2 chips or 2 modules installed in parallel. Okay. So understanding how RAM works is really important. Any question? Okay, again, all of this information you can find from our notes. Your SRAM and your DRAM, that's starting from page 1 going into the top of page 2. So RAM is necessary for operating system, period, right? Now when you buy a mobile device, the more RAM you want, the more expensive it costs, right? Storage is of high demand. With that, you're able to store more pictures, videos, run more applications, and so on. So one of the things that we need to talk about is that it uses an address similar to what you've seen on a hard drive. All your memory storage, no matter whether it's a drive or it's a memory module, it uses a form of address. This is how the system can locate what is stored at what location. So think of it like a physical location on the chip that it can be identified by the system. So in case it needs to retrieve it, it's going to go to that address. An example of this is like you have many houses on the block, right? And each house, you would have different people living there. So the city would have a way to associate who is living at that particular resident, right? Using a home address. So the computer uses a memory address to find, right, what is stored at a specific location. So it's going to break down to two categories of addresses. Number one, a physical address, like your home address. Who's living at that home address? And it's going to start with raw memory dumps. So you often see it's referred to as memory dumps. And it's considered like an offset. Now, when you store it into the space, right, it's going to chunk it into a certain size. So when you're looking at a virtual address, this is stored on an actual hard disk, but used as a memory type of address. So because RAM is limited. So let's say that I only have 4 gig of RAM and I'm running a lot of application. The operating system actually capitalized on the extra space that we have on the hard drive to be able to use it as a memory address. And this is known as pages. Things like when you are running web applications, it would load like the virtual type of storage or memory, and it uses a virtual addressing. So this is a way that it would be able to read the pages on RAM or the storage. In like virtual memory is on the hard disk, and then on your RAM is actual memory storage. Okay. So here it talks about how it is 4 kilobyte in size, and your processes are able to read the data in pages on the RAM using virtual addressing. Now, let me see if I need to close that. So for number 4, it says, what type of memory address is used for memory dump? Yes. Okay. What type of memory address is used for memory dump? When we know that memory dumps is referred to the physical address. Think of it like your home address for that street, right? And you would see it, an example of it would be like this. You would see a hex value, right? We saw the hex value before, which is indicated as 0x. So when I say a hex, right, all addresses are hexadecimal value. So let's think of it like this number on the right side here represents an address for a certain information. Like this. And it's considered an offset. So normally what you would see is it would increment by a certain size. So let's say that it depends. In Windows environment, it does a double word for a 32-bit. So a word is a 16-bit. And when you have a double word, that will be 32-bit. Now, most of our modern system is 64-bit, right? As you install your Windows 11, it will tell you it is a 64-bit OS. That means that it uses quad word, 4 words, and each word is 16-bit. So when you're looking at the actual offset, like one house to the next house on that block, right? You would see that there is a certain size that's divided. That means that it's 16-bit for each of the house. So I can go from the 00 hex 00 address to the next one, which is 16-bit later. That's 2 words, right? In the case, oh, I'm sorry, 1 word. So what you see is it would actually chunk up or divide up a certain bit size to be able to write additional information. So if I'm looking at this address might store some information about the application, it doesn't necessarily go to the next address, right? When we know that our memory is dynamic, so it can refer to a different address down the line, okay? But if I go from hex 00, right, 304 to 308, that's gonna be another word, the next address up. Like the 5 would be a 16-bit apart, the 6 would be 16-bit apart. So if I go to 8, right, I just take 4 times 16, that's gonna give me 64 in between for the bits. Okay. So when you're looking at USB, it's a very similar process, right? If you're looking at a USB, let's say that I have a 512 megabyte USB, the more storage size you have, the more addresses it's able to contain, right? That means that you're able to store more. So if I have a lot of information, I'm able to put it at different addresses. Just think about that, right? If you have a very large street with a lot of houses, you have more people living there. And that's the same thing with your actual storage. So when you're buying something like a terabyte drive, that means that your terabyte drive just have a lot more addresses compared to 100 gigabyte drive, right? So it's able to store in each information, or the set of information is stored at each of the address, and you just have more set of addresses onto the drive. Is the drive physically bigger? No. Logically, they just created it where you would have more addresses allocated for that particular drive, right? And that's built onto the chip. So the chip cell, there's some physical difference, but physically, when you open the package, it looks exactly the same. You look at one USB, right? It's 32 gig, and another USB is 4 gig. So one just have more addresses than the other ultimately. Okay. So that's how memory or storage usually works. Any question? Okay. So when you examine your memory, these are the things that you need to remember. Number 1, the processes that were executed at the time of the capture, right? That really tells us the activities that's happening with that computer. And the data that was stored within the RAM. So you need to make sure that you document this well before you begin performing your investigation. The type of RAM the system is using, like we would say this, the size of the RAM, the type of RAM, and sometimes even the model of the RAM. But sometimes you have to open up the system in order to examine that, right? So we document, we need to find the processes that are being executed at the time of the capture as the system is still running. Now, if you have a system that's shut off, right, there's no processes that's really running. All the processes has end. So when you reboot the computer, RAM is being utilized again, and potentially that space can be rewritten, right? Can I still find information in RAM? You can, right? And also with flash technology, and this is what happens is even when you delete images or files from your SD card, right? We know that files can still be retrieved if they're not overwritten. So RAM technology is very similar to that. Even if you had powered it off, some remnants of the data might still be there. So you might still be able to carve and find it, but likely that, your RAM has been rewritten. Okay. So when you look at memory dump, we need to examine the current processes, looking at the timestamp when that was being executed, and then the starting addresses. Okay. Because it's going to tell us where physically, right, that process information is stored. So if you understand processes, right, your computer needs to fetch it. Okay. So when I'm running an executable or an application, many processes get loaded to the list, right? So let's say that you open an app. The processes for that app, let's say that I'm using Google Map on my Android phone. Google Map uses many things like geolocation, right? Screen, a lot of things, hardware components. So that means that the processes for all the hardware to be able to present you with Google Map and the direction that you need on Google Map needs to be loaded into RAM, right? And from that list, it's going to be able to fetch it and be able to put it into a certain storage location. And then the processor is going to go there and execute it. So RAM is not just one location. Sometimes you're going to see multiple addresses because number one, it's going to load it onto the list and it's going to take that, right? It does a prefetch and the fetch. And the processor is going to go and then obtain it and be able to queue it and execute it. And this happens in nanoseconds, right? With the amount of speed that we have. So what happens is you are going to have starting addresses and the ending addresses that you see on the RAM because it moves, right? Your process actually moved from one location to the next, to a different location, I shouldn't say next, as your process is being executed by the processor. Okay. So on the low level, we do see that your addresses is also get updated. Okay. And then that means that the starting addresses, that space, right, for that beginning, the prefetch is going to be available for the next and so on. And so you would see that it's queued. And computer science students, when they do assembly, they see a lot more of this. But what you think about is you think about like how it would be like a transfer process, right? You put, let's say that you need to move all of these people from one location to the next. You're going to put them into a temporary location. You take attendance or roll, and then from there, you're going to load each one onto the bus. And that bus is going to take them to another location where they can be seen or visited or whatever. So that means that you have a starting address, and then also your addresses get updated as your process are being executed. Any question?
Why is it called a thread?
I'm sorry?
Why is it called a thread? It's in process, right?
A thread?
Thread?
Like thread like this?
Yeah.
Yeah, so it's a way that we can have multiple processes being executed at the same time. Thread technology been around for a long time, and it was really like an Intel based design. So when you create a process or you use, so your application, your system use many different processes. Let's think about it. It's like you have to do a task like paint a house, right? You don't just go and use brush and a paint bucket. There are other things that you need to do. You need to cover the floor, you need to prep the wall, you need to mix the paint, a lot of things. So these threads are able to be distinguished and be able to accumulated and executed by the processor. So that way we're not clumping it to one thing, right? Because each process is for different tasks, right? So, and then, but I'm able to do other things. So let's think about, let's like 5 workers is painting that wall. So one worker can tape the wall, the other one can start painting, right? So what you can have threads that are doing different things simultaneously, and that's what we call multi-threading, right? So, and that gets your computer faster and it's able to spit out things that you want faster.
Oh, wow.
Okay.
Thank you.
Yep. Okay. Let's talk about operating system. Your privilege separation. This is your user account or your user privilege is different than your system privilege. This is being isolated compared to your kernel's actions. So on the low level, there are certain things that the user cannot have control over. And you see this with files, right? When you open the files, when you look at the processes, the system it has its own set of steps that it needs to do. So your system operates it on a trusted mode, right? Which is the kernel mode. And then your user application, which is what you have control over, is on the untrusted mode. Now, you do have malware and other things that are impacting at the system mode, right? I got an email from the student last semester during summer asking about like the cheat code for some of the games in the PC. And then with the cheat code and some of the game, right? It actually access at the kernel level. And that what happens is you're intermixing what the user is interacting at the trusted mode. And that's dangerous because that changes the landscape of what the system operates, right? So the community is saying that, and all the cheat code right now doesn't operate otherwise, right? So if you install it, it operates at the kernel mode. Okay. So, and then for the system call, this is to access resources in the kernel level. So think of it like a layer that the operating system is really designed upon, that's used, right, to make requests for your processes. So if you're looking at like an Android phone, if I touch the screen, that's a process, right? It sends your finger, and at the low level, it needs to access the hardware to give you your screen and your touch component, right? But it's coming from the user application into what you see on the system call level. So that way your kernel can be accessed for the operating system to present to you what you see as, you zoom in on the screen or you touch the screen. Okay. And then it has process management, which allows us to end the process or, utilizing that. But ultimately, memory dumps is going to store all of that information. Okay, so let's answer these questions. 6, explain how hibernation file works. So when you use Windows and you set your system into hibernation, right? So when I put it in hibernation, it does a few things, right? It doesn't consume power. It put my system in temporary sleep, but it remembers what you have open, right? So right now, if I set my system into hibernation, it's going to remember if my browser is open, right? When I take it out of hibernation, it needs to revert my system back to the state before it goes to sleep. So that means that it needs to create a file. And that file is called hyberfill.sys. This file contains the system content or information before it goes to sleep. So RAM then is compressed and it's going to store this file. This allows the system to then stop the power, right? Basically, you power down. So when I put my system into hibernation, ultimately, I want to save resources like consuming power, right? Consuming network connections and all of that. So it's going to power down the system, but so it needs to save the state of your system. That means that when your system is reactivated again or turned back on again out of hibernation, it needs to go to that file, retrieve the content, put everything back into memory, and be able to open the application that you had open before you go into hibernation. You guys understand? So that means that whatever that you were doing before hibernation, it stores it into that file, right? It compressed the RAM and store it into that file. But when you take your system out of hibernation, it takes the file information and put it back on RAM so that way everything would go back to before you put it to sleep. So that's why it remembers. Any question? Why do we care about this? Well, if you get a system that's in hibernation and you do forensic, you go to that file, right? That file does store whatever that was currently working before hibernation. Okay. So here it talks about the type of information that you can find content of RAM. Configuration information that's important. Your system settings, configuration, also executing commands, right? Commands are actions that your system takes. It's different for every level. So when I click open something, your system sees that, right, as a command, right? We use terminal, so you understand that, right? Password, encryption keys, unencrypted data, IP addresses, that's important, right? We talked about network connection, internet history, chat conversations. So later on, when we do Android and iOS analysis, you're gonna see this, right? It's gonna pull up all the conversation, like from WhatsApp, from social media. If you're on, any kind of chat, you would be able to find the conversation. Emails, that's useful. And then also malware. We talked about malware already. And then hibernation information is on this page, page 3. So the file header for hiberfill.sys, it would be HIBR, right? Or it would be HIBR in capital. And then when you take it out of hibernation, it becomes a wake file, right? It replaces that with a wake file. And then your page file, this is for your virtual RAM. Virtual memory is actually this storage. I mentioned that earlier. And it saves everything as a page file. Okay, so let's move 6 down. So what is stored on your page file? Your program data that exceeds the capacity of the actual RAM. So let's say that you're playing a game that requires more memory than what you currently have, and you don't have supplemented memory in your video adapter, right? This is why gamer want to have a better video card, because they would have a good cache size to store all of that information for their game for the visual effect, right? But so if I'm playing it on a very simple computer, I would then need to capitalize on my hard drive space, right? Which is, if you're looking at the root volume for OS, like Windows, that will be your C drive, and your page file will go there. So it is a way to supplement your RAM when you don't have enough, right? Your system use hard drive space to supplement for what's lacking in the RAM area for that application. So that means that we need to examine the RAM and the virtual memory on your hard drive. Any questions? So make sure we know the difference between your physical memory, right, which is on your RAM, and then your drive, right? When the computer was first conceived, everything was in memory, right? It was very tiny. It was really the storage back then in the 40s were really designed to do arithmetic. So you don't really have a lot of storage like what you've seen today. And even when I started in the field as a tech, drives were 40 gigs or 60 gigs or 80 gigs back then at the most. And you couldn't have more than, because it's MBR, you couldn't have more than 4 drives. So later on, you started to see more storage technology become more available. Now you see with solid state drive, and then your memory changes too, right? We went from a very small amount of memory to modules that contain larger size. Microsoft claims that you can have up to 192 terabyte for drive and then very large storage. I think most of the motherboard now support uh anybody at 128 gigabyte yet? I don't think so, right? Like it's 64 gigabyte of RAM. Okay. So let's talk about memory dump and what they are. You would have a complete memory dump. This contains data on your physical memory, your RAM. Not common because the capacity of your chip. Kernel memory dump will contain pages of data from the kernel mode. Remember, we talked about the kernel mode is your trusted mode, and your user mode is the untrusted mode for the OS. Small dump files contain information about running processes, loaded drivers at the time of the crash. So in the case where if you have malware that caused crash, you refer to small dump files. That's going to give you the processes that were running. And malware loves driver, right? Driver are programs to control hardware, okay? And so malware, a lot of the time they design to do something like send out information to another server or another system. So that means that it needs to activate, right, your network adapter and your storage. Storage is where it's going to be able to retrieve the data that was stored, and network adapter is able to send the data to another system. So any question? So we want to make sure that we look at various type of memory dump depending on what you're investigating. Often you see these. Yeah, so when you're dealing with malware, right, you often see these too. But in the case if you want to obtain the complete memory dump, then you would be able to pull that, right? There are technology or software that will be able to analyze specific things for the memory. Any question with memory dump? Okay. So for your crash dump, that will be memory.dmp. This is for Microsoft Windows. So when you get that blue screen of death, right? That will be your crash dump. So this occurs when your memory is not able to retrieve or store accordingly. It is a software issue. So often that you would have like a crash dump. So blue screen of death is a good example of that. And then the answer for the last one that we did is here. So if you need to examine this in your registry, your Windows registry, this is where you can find it in the Hive. Crash dump enable. You can convert the dump files using another tool, right? Because sometimes you can't just analyze any kind of file. Your system's going to want a certain application to be able to open up that file. So you need to convert it. Okay, so the next part here, it talks about scientific work group on digital evidence. This gives you volatility data and some additional information regarding how your storage is used for data storage. Okay, be able to get some information about driver, about USB. So in RAM analysis, what effects of using USB devices on your system memory? When you plug in a USB, it automatically changes your system state by updating the memory. That means that the system is going to load the USB device driver into RAM. And in a lot of cases, you know how you plug in a USB and it opens up another window to show you your USB content, right? That's an auto run that's initiated, and that comes from the driver of the USB. So with that, it would load the driver into the Windows registry. Okay. And this is important to think about because, you know, as a user, sometimes we don't really see a lot of like the behind the scenes side effect of plugging things in. But in forensic, every single step can change the outcome, right? So you want to make sure that you're careful with your step. And we talked about capturing the image for the USB and so on. And we don't always, when you have a system as an artifact and you need to obtain the evidence from that artifact, you need to make sure that when you're plugging things in, it doesn't impact the data content of that system. Okay? And then for 10, it says, based on scientific work group of digital evidence, what should you consider when using applications to analyze volatile data in RAM? 1, application used to collect data in memory will overwrite some content of the memory. Okay? So when you're using the application, likely that it's going to overwrite some of the data on the RAM. 2, larger of the tool, the larger the tool, the associated files are, the more data overwrite. So if you have a very large suite or application to do data analysis, likely that you will lose more data because data is overwritten. So this is the cost and effect of using analysis applications. We need to document this in our report and understand the consequences, right? Give or take So you do take a risk of losing potentially important data when you're using applications to analyze your RAM. Because it has to load to RAM, understand? So, and if you need to capture live, you need to run an application, but normally, right, we can also screen the live image from it. So, and this is what they're referring to as doing live analysis, not dead analysis, okay? All right, 11. What are needed in capturing data on RAM? You need to have a storage device to store the image, right? A capturing device, such as a USB external drive. Access to the system. That makes sense that we are trying to pull the image of that system. We need to have access to that system physically and logically. And when you're working even with analysis application, you have to have administrator or highest privilege. So administrator privilege. So those are the few things like access, admin privilege, and then the storage device that you need to store the capture. So what kind of tools I can use to analyze RAM? And this is, the common and also the recommended by the book. However, you do see new tools coming to the scene every year. So you want to check those out. You got dump it, FTK memory capture, bulk extractor, Volix, and volatility. These are the mix of tools in different platforms. Some of them are used in Linux, some of them are used in Windows system, right? We can use bulk extractor with the graphical user interface in Windows system. Volatility version 3 is what we're currently using for the lab that you can use in Linux system. So there are tools that are designed for certain platforms. So make sure that you look into the tools before and test the tools, of course, before using it. And down the line, you will have a lab using bulk extractor. So you will need to, I think that one, I don't think I installed it for you, but bulk extractor does require a lot of system resources. So any question? FTK as a suite, you do have access to the memory capture in that suite. But you can have that feature on its own as well. And that's all she wrote for today. But I want to capture some of the notes information before we take a break. We have a light lab. I just Crydex get moved all the time, and I'll talk about that. So I'll see if we can download it. We might have to analyze another malware today. But okay, so the tools information, you can find that here. There's some link, right? So this tool allows you to also convert. You can use command prompt and it would look like this. There's some tutorial from the company floating around on YouTube. So if you want to watch it. Did I write a lab with dump it? I don't remember. I have to go back and look. And then you can use FTK. bulk extractor from Digital Corpora. I personally like bulk extractor. It's very similar to Pro Discover or um the one that you've used, Autopsy, right? You do have like scanners that are integrated like this, wordless. We saw some of that in the last, like for the hibernation file, you can just select that one. Um, and it would show up like this. So you see, it will give you like the addresses, and so for bulk extractor, it's gonna pull a bunch of things, including like the website that you visited, the application that you ran, even the images that you downloaded. So definitely a useful tool. Volix, so you can go and find information about Volix. So most of these are so if you're using volatility in Linux, there's no GUI, right? That's just command line based tool. You can download the one with the graphical user interface for it. And then just check the requirement. And it does have a CLI only too. Command line interface. I think a lot of people prefer to use graphical user interface because you can click and then it might have report generation type of options, right? So that's good. And this is not a long chapter. I encourage you, when you have time to read through the notes, visit the website, right? If you want to download the application to test, you can. You just need to test it with an image. Okay. I think I'm pretty caught up with the grading as far as yesterday goes. I try to catch up with the Monday and Wednesday class, and then I'll get my Thursday class updated. But I'm gonna stop record. I'll give you a break. Um,
I mean, number 12 again?
yeah, and then